Hello everyone, welcome to my channel on data analytics. Real world enterprises naturally store their data in database management systems such as Postgres and MySQL. Thus, it is important for the data analyst to learn SQL so that he or she can gather the necessary data easily from the enterprise data repositories. In this context, this video covers the basic topics of SQL from the bird's eye viewpoint. Moreover, ample number of examples were provided in this video so that users can easily learn the SQL. We also provide a demo in which we run the SQL commands on a Postgres database to gather the necessary information. The code will be written in Python and executed using Jupyter Notebook. The contents of this video are as follows. First, we introduce the structured query language. Next, we discuss the process of connecting to a database using drivers. Next, we present the pseudocode for running various types of SQL queries in Python language. Finally, we give a demo where we collect the data from a Postgres database using Python language. The details of the demonstration will be explained at the end. Now, coming to the SQL. SQL commands are broadly classified into two types. One set of commands that work on metadata and another set of commands that work on actual data. Metadata represents the description of the data. The best analogy to understand about data is that metadata simply represents the variables in a programming language, such as int x, where int is a data type that is representing the variable x. Similarly, data, on the other hand, represents the observations that we capture for a particular object. The analogy to understand the data is the value of a variable. So, if the users are familiar with the programming language, just assume that metadata is nothing but the variable type and data is nothing but the value of a variable. First, we now look at the SQL commands for handling metadata. Next, we take a look at the SQL commands for handling the data. Coming to the metadata handling SQL commands, first and the foremost SQL command is create. This command is used to create a new table containing attributes and indexes. The basic format to create a table is create table, table name. In the table name, provide braces and define the attributes, type of the attributes, and any constraints that a particular attribute has to be satisfied. You can also define the keys such as primary key and foreign key and the indexes that the table has to maintain. An example SQL query is as follows. Create table. The table name is sensors. So create table sensors with sensor ID as an attribute whose type is int and it is a primary key. Then we have locked as an another attribute that is capturing the geometric information of the sensor, and then we have the address that is collecting the location of the sensor. So if we execute the SQL query, then we will get a table sensors with the attributes sensor ID, location information, and the address. So this is the first query we execute to create a table. Once we create a table, we often alter it to suit our day-to-day demands. So alter is the next SQL query that we do for handling metadata. So when we execute the alter command, please keep in mind that we add attributes, constraints, and indexes. We can also drop the attributes, constraints, and indexes. Also, we can rename the columns and tables. The basic format of alter command is alter table, table name, add or drop or rename a particular column, and we have to define the parameters. An example is alter table sensors, rename sensor ID to sensor underscore ID. So when we execute this alter command, then in the sensors table, the sensor ID will be renamed to sensor underscore ID. This way we can rename the attributes or even we can rename the table name also using the alter command. Drop is the final SQL command for handling metadata. Its purpose is to delete an entire table and its contents. The basic syntax to execute the drop command is drop table, table name. For example, if we specify drop table sensors, then what happens is the previously created sensors table will get deleted permanently. So these are the three basic SQL commands for handling metadata. Now we will look at the SQL commands for handling the data. Similar to create command, which is meant for handling metadata, we have insert for inserting the data in a table. So the basic objective of the insert SQL command is insert data in a table. Please keep in mind that insert always creates a new row. The syntax is insert into table name, the attributes of the table followed by values, and we have to pass the values of that table. For instance, we can say insert into sensors values 1.00 ISO. So these three input values will be inserted into the sensors table as shown in the below figure. Once we do the insertion of the data, sometimes what we have to do is we may need to update the our existing data in a database. To do this, we have the update command. Update command's objective is to update the already existing data in the table. Update command will not create any row or attribute. Only thing it will do is it will change the already existing contents in a row or column. The syntax to execute update query is update table name set column with the values. So we have to specify the column and the what are the values with where condition. Example is update sensors set address to Aizu Wakamatsu where sensor equivalent to 1. What we are trying to do in this update query is if the sensor ID is 1, we want to change whatever is its address to Aizu Wakamatsu. So when we execute this SQL query, the address value for sensor 1 in the table gets updated to Aizu Wakamatsu as shown below. Now, what we have to do is sometimes we may need to delete the data in the table. To do this, we have delete command which deletes the rows in a table. Delete will not remove columns, it only removes rows. The basic syntax for executing the delete query is delete from table name where specify the conditions. An example is delete from sensors where sensor ID equivalent to 1. So when we execute this delete query, we will be removing the data of of a sensor whose ID is 1. Now look at the differences between the drop and the delete command in SQL. Drop removes the table and the data also, whereas delete command only deletes the data. The table and its metadata remains intact. Please keep in mind drop is a metadata command which is meant to delete the table and its contents, whereas delete only deletes the data, keeping the table intact. The metadata of the table will be intact. So these are the three commands in data that are in synonymous to the create, alter, drop commands in metadata. However, there is one command in SQL that is designed for data and its counterpart does not exist, and that command is select. And this is a very important command for the data analyst because most of the time the users will execute the select data and they extract the necessary data for their analytics. So please master the select command. The basic syntax for the select command is select star or column names from the table where conditions follow. Star means you will extract all the columns in a table, whereas if you specify the column names only that information will be extracted. Example is select location from sensors where sensor ID is less than 10. So if I execute this query, what I am going to ask from the database is give me the locations of all the sensors whose ID is less than 10. In my data set, there is only one sensor that has ID less than 10. So its location 0, comma 0 will be returned back to the user. So this is the basic SQL queries we have. Now we look at the connectivity. So there are basically two-tier and three-tier architectures for connecting to the database. So let us see how this architecture exists. Let there be a database running in a database management system. The database management system is a software such as MySQL, Postgres, and Oracle. So, the database management system connects to the database using a username and a password. Now, this entire system will be running on a server having a host name and the IP address. The user using the Java program or any program connects to the database using the driver. This driver is generally called Object Database Connectivity or ODBC. So, for the any program to connect to the database, it has to specify the following parameters. One is the host name of the machine, then the port through which the host machine communicates with the database management system, the username, the password, and the name of the database. So these five parameters the user program must contain for communicating with the database management system. We now look at the pseudocode for connecting to the database and accessing the data. Before we look at accessing the data in a database, we first need to download and install the ODBC drivers or adapters. If we are going to use Python and your database is Postgres, then you can install scikop2 binary using the pip command. Once you install this driver, then we can write any Python program to access the data in a database management system. So let us look at the program. Any program that we write for reading the data from a database has five steps. The first step is establishing the connection. Once we establish the connection, next what we have to do is we have to create a cursor object. Once we create the cursor object, then we execute the SQL command. So here we have to remember that if our SQL command is read based, that is select query, then what we are going to do is we are going to fetch the results of the select query. Once we fetch the results, what we do is as the final step we can print or do further processing on the data. So these are the five steps for reading the data. Now, if we want to write the data into the database, Then the syntax is given on the right side. The first step and the second step remains the same. In the third step, we instead of using select, we execute insert, update or delete commands. Once we execute these write based commands, then what we have to do is we have to execute commit, because we are not going to read any data. Instead, we are modifying the database. So once we modify the database, we say commit the modifications we made. Please keep in mind that if you forget to commit the database and if we close the connection, then those changes will not be reflected in the database. Now we look at a small demo. For demonstration purposes, we are going to use the sensor location data generated by the Eros system. So what are the tasks we are going to do in this demo are as follows. First, we try to log into the Postgres server and then we create a database. Next, we enable the extension PostGIS so that we can store the location data. Then we create the table to store the data. Once we create the table, what we are going to do is we are going to write the Python programs. One, to store the data into the table from a file. The next program will read the data from the table and then find the location information. So let us see the contents of the station info table. So if we see, we have 1, 2, 3, 4. We have 4 columns in this file. The first column is just a row number. The second column is the station ID. The third column is the location information of the sensor, and the final column is the actual address where the sensor has been located. We now try to store this data in a database. So the first step is we have to connect to the Postgres server. So let us connect to the Postgres server using pl-u username localhost. Just that 1 4. Now what we have to do is we have to create the database. So coming back, let us create the database. Create database. Sensor. So let us say this is our table sensors. Now what we have to do is we have to connect to the database sensors. Now as you can see, we have now connected to the sensor database as the user test. Now what we have to do is we have to enable the extension PostGIS so that we can store the location data. So we say create extension PostGIS. This will create 3 tables which are specific to PostGIS. We generally do not touch them, so please avoid touching these tables. Now what we have to do is we have to create the table to store the station information. So now let us create the table. The SQL command to create the table is create command. So create table. Let us say our table name is sensors info. Okay. So in this one, I remove the row information because that is not needed. So I will say sensor ID, which is a integer and it cannot be null. If we want, we can also add it primary key. Then we have location. So let us say location. This is the earth's point on the earth surface. So we have to say geography. Sorry. So this is geography. The data type is geography where I am going to store the point information. If you know the projection also, mention the projection. Otherwise, you can leave it as it is for the default projection. Now, we will type address, which is a where. So, now we are creating the sensor info table. See, we have created the table. Now, let us see its contents. As you can see, we have created sensor ID attribute with the data type integer. Then we have created a location attribute with geography as the data type. The default projection system was given, which is 4326. That is why we have not mentioned it. And then we are storing the address as a varying character. So now we have created the database. Now what we can do is we have to store this data in this table. But the problem is we cannot do it manually using the insert command. So what we will do now is using the Python program, we read this file and try to store it in the table. So this is our fifth task, that is that reads the file and inserts the contents in a table. So I have already written the sample code in the interest of time. So let us try to make a copy of it and try to run it. So first what we have to do is we have to read the file. So I am reading the file and storing it in the CSV object. Okay. So after storing it in the CSV object, now what I have to do is I have to traversal each line in the CSV object and I have to store it in the database. So first what I am going to do is I am going to import the driver. Next, I will create the connection. So in the connection, we our database name is sensors. You can see here our database name is sensors. So we are creating a connection to the sensors database using the user account. Once we create the connection, next what we have to do is we have to create the cursor. So let us create the cursor. Next what we have to do is we have to traversal the each element in the file object and we need to insert it in the table which is sensors info. So using the for loop, we are traversing the each row in the file object and we are trying to create the SQL command. So our table name is sensors. Let us check sensors info. So here, so insert into sensors info values which are from column 2, column 3 and column 4 because row 0 represents column 1, we will have plus value. So we create the SQL query and then we execute it in the database. We have now executed the query. Now what we have to do is we have to do the commit and close. So generally we should not put them here. What we have to do is we have to add them here. Okay, if we put them here, sometimes they will not commit. So let us run this entire thing. So now we have made the commit and we have closed the connection. So let us check the data. Let us say, so this command will tell us how many columns have been inserted. You can see we have inserted 1747 sensors or rows. Let us check the file also. You can see this file also has same number. So we have inserted every row in this file in the database. Now what we are going to do is, now we have inserted the data in the database. Now we will try to connect to the table sensor info, get the location information, and let us try to show it on the map. So this is going to be our sixth task, that is read the table information, read the sensor information from the table and display the location of sensors on a map. To do this, now what we are going to do is, first we have to create. So let us create one more so we can have gap. So again I am importing the library. I have to connect to the database sensors. Now what I am going to do is I am going to execute the select, because I am going to read. I am executing the select query from sensors info, which is the table name. And once I execute this query, whatever the output I am going to get, that entire output fetch all is going to store it in this rows. So this is not station ID. So let me check. This is sensor ID. We have now collected the rows. If we want, we can print the rows and we can see the result. Okay, so we have the data. If we press the rows, we can see the entire data here. Okay, now what we are going to do is, the column data we got, we are using the zip command, we are going to separate them. Okay, so I am separating the 1, 2, 3 columns into names, second column as longitudes, and then third column as latitudes. Using this, I am going to create the data. Once I have it, next, using the Plotly Express, I am going to print the location data in the map. So here we will see the location data. That's all for the demonstration. Thank you very much for viewing our video. If you like our work, please press the like button, share it with your friends, and subscribe to our channel for latest updates. The material that I have shared or shown in this video is available at the GitHub link, which is also provided below. If you want to know more about knowledge discovery in big data, please check the playlist.